Okay, well thank you. It's a pleasure to be here today. So we've been discussing a lot about hard science to an extent. Now I'm going to bring the conversation to digitalization and specifically to edge computing. So I'm from a company called IoT One. We're a research firm that focuses on the industrial IoT space, but industrial IoT is extremely broad, right, in terms of the tech stack and in terms of the vertical. So I'm going to today focus on edge computing. It's also very broad, but it's, I think, particularly relevant to the types of companies that we have been discussing with today, because if you're doing process manufacturing, if you're doing logistics, if you're doing asset management in the field for agriculture or for energy management, then somehow you're probably going to be using edge computing technologies. And it's also, I think, relevant because we're all looking right now towards February and the next 5-year plan, and edge computing is certainly going to be one of the priority areas in that plan. So what I want to share is a little bit of research that we did over the past year for a couple companies that we work with around edge computing developments in China and also globally. I'll skip over this, skip over the intro. So edge computing, first of all, how do we think about edge computing in the context of computing? So we moved from the 70s, we have the mainframe computer where you have a few tens of thousands of computers in the world, towards the PC where you have hundreds of millions, billions of computers, and now the mobile phone, we have more computers than we have people, right? And we moved from a centralized to a decentralized, and then back to this cloud kind of centralized dynamic. And now edge computing is bringing this back towards a decentralized dynamic where you have computing resources scattered throughout the world. And then the question is, why would we possibly want to do that? Because the cloud seems to really make sense from a lot of perspectives. So why do we want to do that? So edge computing is basically, the logic behind it is that you're taking the compute, or the storage, the compute, the processing, and the networking, and you're bringing it as close as possible to the device that's generating the data, as opposed to mobiles and cloud computing, where you're taking everything up into a centralized location in the cloud and processing the data there. And close is a relative term, which we'll explore in a minute here. So it could be on servers that are co-located with cell towers. It could be on-premise servers in a factory. It could be on a gateway, which we have kind of scattered around the ceiling here. It could be directly on the operational device, right? So now we have chips, for example, that can do fairly sophisticated processing on very low power devices. So this might be what we would look at if we're thinking about what where computing could be done on the edge. So we have the real world down at the bottom, the equipment, machinery, pigs, people, right? All the places where a sensor might be deployed and you might be trying to gather data. And then you have the cloud up at the top, which is sitting somewhere in a building that has no windows, somewhere in the suburbs, or on a barge. And now you have the edge, and the edge could be anything from the devices, again, like the gateways in the ceiling here. One of the edge computing topics that's kind of quite interesting lately, and I'm going to share a startup that's working on this in a moment, is 5G cell towers. So with these 5G cell towers, they service an area of, depending on how many buildings are around, between a couple hundred meters to about 500 meters, and they provide extremely good latency in that area. And so if we can build an edge computing data center, basically the size of a shipping container, we put that right by the 5G base station, then everything that's done in that vicinity can basically have instantaneous and really no cost access, because then you're moving from an OpEx model where you're paying Alibaba or you're paying AWS to move your data, to a CapEx model where you say, okay, I'm a factory, I'm BASF, I'm going to put a data center here with a 5G hub, and I'm going to own that CapEx, and then I can manage all of the data around here with a CapEx cost base instead of this OpEx cost base. So that's a big topic of innovation on edge computing now. So what are applications? One of the issues here is that we talk about edge computing, we talk about cloud computing. The reality is that most situations are going to be a mix, right? sometimes pure edge, sometimes pure cloud, but often it'll be a mix. So we can talk about things like whether you're driving yourself or using an autonomous vehicle, maybe in 5 years. Identification of road hazards. So this could be from sensors on the vehicle, this could be from cameras. Fortunately, in China, we have about 300 million cameras on the street, so the cameras know what's happening, right? So that data could be streamed to the car to know, are you running into an issue. When we talk about improving flow of traffic, we can look at, for example, where are the street lights ahead of me? Where is the traffic ahead of me? Looking at parking spots. So we have data points that are kind of scattered around the city, and right now, we are typically just eyeballing them. We're trying to figure this out as we go. But of course, when we have 5G base stations set up and we have this data somewhat centralized, we're able to access that through the vehicle and make better decisions or autonomous decisions in vehicles. If we look at a construction site, we also have a lot of discrete data points that we might want to track that are very valuable locally, but not very valuable globally. So there's no real need to move them to the cloud. So how many people are on site? Are they the right people? How much water are we using? How much electricity? What equipment is being utilized, etc. So there's a lot of data points that are valuable to the operators on site, but they're not valuable generally to people outside of the site. So this would be a case for edge computing. This is a list of 20 of the more common industrial IoT use cases. And we just identified here which are the ones that would be typically done on the edge, which kind of need to be done on the cloud, they're not really possible without the cloud, and where might you be able to make a decision, right? Where do you want to go? I won't go in detail through this, but obviously the IoT is kind of interesting because it's a very, very long tail of use cases. There's really hundreds and hundreds of potential use cases, and in each one you have to think through carefully, where should the compute be done? And that's what's going to drive the investment decisions around, or let's say the market sizing decisions around where money is being spent on computing technologies. What are the types of technologies that we're considering here with the edge? It maps, still fairly well to the traditional industrial IoT tech stack. So, well, I think one of the interesting things here for me is that there is an incredibly large number of stakeholders that are involved in the edge computing market. So you have, of course, the expected suspects. You have the Bosch and Advantech and so forth that are building the hardware components. So those are the guys you would typically think about being edge computing companies. But you also have companies like Tesla, right? DJI. Obviously, these are edge computing companies, right? DJI does, it's very important that they can do processing on the edge to be able to both operate their vehicles and then also provide services built around those vehicles. Then we have, of course, applications that are designed for compute on the edge. We have a whole set of analytics, and this, I think, for venture capital in China is a huge area to focus on, is analytics for the edge, because most of the sophisticated analytics for the edge companies right now are American. And it's very difficult for them to enter into the Chinese market, right? Because these are kind of sensitive use cases. So I think there's a big gap from at least what we see in the market in edge AI or edge analytics for industrial among Chinese startups today. Of course, there's a lot in the cloud, but those are not very transferable to the edge, right? In the cloud, you have unlimited processing power. So you need a kind of a different framework in order to be able to do edge analytics on the edge. So one company I want to share with you, a company called Turbine. This is actually somebody else's box. I just superimposed their logo there, but same concept. So what they do is they build kind of a Google for IoT data. They aggregate IoT data from primarily government sources. They're mostly working in the US right now, so they'll get it from the Transportation Department, the EPA, etc. They aggregate this and then they turn it into a marketplace where if you're doing research, you're an automotive company, or you're operating a business and you need access to data around weather conditions, road conditions, whatever that might be, you can purchase access to that database. So that in itself is very interesting, but then what they've realized is that data becomes stale. It gets old, and as it gets old, it loses value. So data has the most value when it's fresh, and that means you need to make it instantaneously available in many cases, right? So what they're doing now is, again, they're building these these data centers at the base of 5G base stations, and then they're providing this as a service to everybody operating within the vicinity of that. So if you're, for example, operating a fleet of automated taxis in 5 years, you would need to know, one, where all your vehicles are. So you want the vehicles to communicate with each other. You want the vehicles to communicate with the city infrastructure and all the other sensors that the city's deploying around traffic and so forth. And you don't want everything to go through the cloud, because if you're driving a car, a half a second delay, right, in a data transfer is going to cause an accident. So then you would use this type of infrastructure. So there's going to be a lot of investment in from quite a number of different companies, including data centers scattered around the cities and connected to the 5G infrastructure. Just a couple of quick thoughts to end here on China. So China is particularly interesting in this edge computing topic from a market perspective, because first of all, you have this enormous 5G investment and a very strong strategic push from the central government. Second, you have a lot of cellular IoT connections in China, and also non-cellular connections. So Chinese infrastructure is relatively heavily connected already. And then you have actually quite impressive awareness among Chinese companies, or excitement, let's say, around the business potential here. I think it's probably a little bit unrealistic to expect 90% of companies to generate incremental revenue from edge computing, but at least according to GSMA, 90% of companies in China do believe that they're going to generate incremental revenue improvement. And that is benchmarking against other companies. That's at the top of other countries. That's at the top of the responses globally among other countries. So more companies in China, for example, believe that they'll generate incremental business in China than in the US or in Germany, as examples. So there's a lot of excitement from business about the potential here. If you're interested in learning more about this topic, of course you can contact me. I'd be happy to have a chat. But you should also look into this organization, the Edge Computing Consortium, ECC. So this is a Chinese kind of quasi-governmental organization run by, founded by Huawei, Shenyang Institute of Automation, which is under the Chinese Academy of Sciences, Intel, ARM, so has a little bit of a multinational membership base as well. So this is, on the one hand, it's an indication that the government is trying to build structure around this topic, but it's also a great network to connect with the companies that are invested, including a lot of startup companies in the space, and to learn more about where the market is moving. Yeah, and just a last point here, if we look at kind of from an ecosystem perspective, who is playing in this market? We have really a wide range of companies coming from the traditional automotives or automation companies to the OEMs like SANY, end users like higher, so white goods manufacturers, and then of course the ITC company or ICT companies who are investing very significantly in building out their edge computing capability. So Haier is one of the more interesting examples here, because they're viewing themselves as a company that has the potential to be the Chinese Siemens, right? So of course, they're coming from a white goods background, but what they're doing now is they have their Cosmoplot IoT, industrial IoT platform, and they're basically either building or purchasing components and building up this large database of edge computing components, actuators, sensors, and edge computers, so that they can bring this portfolio to market, this kind of smart factory or smart industry portfolio to market. And the reason they're doing this is because there's no Chinese incumbent, right? That it's who has the right to win, why not us? We understand manufacturing, right? We have scale. So there's really an interesting market here in terms of huge opportunity to scale, very strong government incentive, and at least no local incumbents. The incumbents are primarily European or American. As an American, I hope that we continue to play in the game here. But obviously, there's going to be some localization in the market in the coming years. That's what I wanted to share. I hope it was somewhat interesting, and again, if you're interested in learning more about edge computing, I'm always available for a conversation. Thank you.
Thank you. Thank you for the review for the industry. Just before we move into the next session, does anyone have any question for our keynote speaker? Please raise your hand. Oh, yes, please. Can someone pass the mic?
Just a simple question. What could be done in 5G with edge computing that could not be done with 4G? What's the difference? What does it mean?
In a lot of use cases, it doesn't matter, frankly. So if I'm using in an automotive factory and I have a vehicle that's kind of delivering spare parts, that's okay. 4G is good enough with some lasers and so forth. If I'm using AR, I need 5G, right? Because the latency mix is going to give you a headache. That latency from 4G is going to give you a headache. If I'm doing anything autonomous vehicle on the street, 4G is not going to cut it. So I'm going to need a combination of probably 5G plus also lasers and so forth. But again, the latency. So any use case where latency becomes a big, either a safety issue or a user experience issue, 5G is going to be a big step ahead.